Fluorinated gas reduction technology, the main cause of long-lasting man-made greenhouse gas, F-gas. Unlike other greenhouse gases, F-gas has no natural sources and is generated from a variety of industrial fields, such as aluminum and semiconductor manufacturing factories. In addition, the gas remains in the atmosphere for several thousands of years, and it can be decomposed at high temperatures above 1,000 degrees Celsius. F-gas is one of the most powerful and long-lasting greenhouse gases produced by human beings. It can be mixed well and diffused simultaneously in the atmosphere. Since 2013, our center has proposed new strategies to significantly reduce F-gas through the following R&D. Pre-after treatment system for the non-CO2 gas abatement system by use of catalyst and high ionized energy. Integrated system for separation, purification, recovery, and reuse of fluorinated gas emitted from the electronic industry. Thermal destruction and pollutants control system for used hydrofluorocarbons. High-efficiency recovery and separation technology for discarded refrigerants recycling. High-performance abatement technology for pre-fluorinated compounds and nitrogen trifluoride with high destruction rate and energy efficiency. Pre-fluorinated compounds treatment and recycling system using reaction-enhanced RCS. Small-scale air cooling system using eco-friendly natural refrigerants. Greenhouse gas removal system by using combined pump and scrubber technology. Developing project of pre-after treatment system for the non-CO2 gas abatement system by use of catalyst and high ionized energy. Sulfur hexafluoride, which is generated in semiconductor and LCD processes, is a representative gas causing the greenhouse effect. Direct oxidation technology and plasma technology have been used to treat the gas, but reduction efficiency and high installation and operation costs have been problems. Our technology enables batch processing at the final exhaust and can be applied to the existing process. It can perfectly respond to the sulfur hexafluoride problem occurred in semiconductor and LCD process. The system applied automatic cleaning electric dust collection technology was applied to pre-treat hydrofluoric acid, dust, mist, etc., including sulfur hexafluoride in the environment of discharging complex pollutants of semiconductor and LCD processes. After capturing more than 95% of particulate matters, it was irradiated with an electron beam that generates high ionization energy to ensure sulfur hexafluoride treatment efficiency of 95% or more. To discharge some sulfur hexafluoride gas not treated in the atmosphere, catalyst treatment is grafted. SF6 gas activated in an electron beam can react at low temperatures compared to conventional catalyst treatments. In the result, technological advances have been made to dramatically improve performance and lifetime of a catalyst. Sulfur oxide and hydrofluoric acid generated after a decomposition process are treated by the simultaneous absorption system in the final step. The structure, considering the fluid velocity and the increase of a cross-sectional area for absorption performance, is reflected to build the stable final air management system. Our system is applicable to both existing plants and new plants that do not have greenhouse gas treatment facilities, leading to reduction of greenhouse gas emissions with high treatment efficiency and low installation and operation costs. integrated system for separation, purification, recovery, and reuse of fluorinated gas emitted from the electronic industry. Many of greenhouse gases emitted in the electronic industry were not controllable. Our technology is a new pre-fluorinated compound gases separation system that can separate nitrogen and PFCs gases and reduce unnecessary energy loss from existing methods that require large amounts of energy to treat pre-fluorinated compounds in the exhaust gas. The water cyclone process, or a pretreatment process, removes powder, moisture, and acid gas contained in the exhaust gas, compresses the exhaust gas by a gas compressor, and supplies it to the system to maintain stable system performance, even in the long-term operation. Our system separates the pre-fluorinated compounds gas through hollow fiber membrane connected in parallel. Nitrogen is discharged into the air, and concentrated pre-fluorinated compounds gas is reduced up to 50% inflow loads to the scrubber based on the recovery rate of 95%, through which we can expect low expenses and high efficiency, from increase of treatment efficiency to reduction of treatment expenses and greenhouse gases. Thermal destruction and pollutants control system for used hydrofluorocarbons. Thermal destruction technologies are applied to treatment of hydrofluorocarbons, a used refrigerant generated during disposal of various air conditioners and refrigerators. But expensive treatment cost and a large amount of fossil fuel are consumed. Our system has adopted a technology to improve the energy efficiency by breaking the highly stable refrigerant at high temperatures, and simultaneously to cool the inner wall of a combustion chamber with combustion air. The process of disposal of used refrigerants is to inject the used refrigerant after preheating them by using auxiliary fuel to decompose them into carbon dioxide, hydrogen fluoride, and water. Hydrogen fluoride, removed by reacting with the neutralizing agent, carbon dioxide and water, etc., are discharged through the stack. The wall of a combustion chamber is composed of a double structure, so that the combustion air flows in a fluid path between the outer wall and the inner wall, and rotates 180 degrees along the wall of the double structure. Combustion air to help cool the inner wall of the combustion chamber forms air curtain and prevents corrosion by acid gases. The combustion air that rotates along the inner wall will join strong turbulent flow formed in the center of the burner. The used refrigerants supplied to the burner is completely decomposed at the maximum temperatures of 1,200 degrees. In addition, some of the cooling air of a burner used at this time is replaced with recirculated exhaust gas discharged through the chimney to reduce nitrogen oxides and improve energy. The combustion technology for thermal destruction of waste refrigerant is excellent in energy efficiency and can prevent corrosion by preventing combustion gas contact. Our technology is a new system that effectively treats used refrigerants without discharging them into the atmosphere by recycling and destroying hydrofluorocarbon gases. High-efficiency recovery and separation technology for discarded refrigerants recycling. Hydrofluorocarbons, one of greenhouse gases, are used as refrigerants for household and industrial air conditioning equipment, but they are substances that increase global warming by illegally discharging into the atmosphere because of no recycling technology. Our technology is the first eco-friendly technology in the country that separates, purifies, and regenerates contaminated or mixed refrigerants with high purity. A refrigerant boils instantly at room temperature as it has a low boiling point. It has physical properties which each refrigerant has different boiling point. Our technology is to sequentially separate and purify contaminated refrigerants with high purity by using different boiling point of each refrigerant. When the contaminated or mixed refrigerant is recovered, heated, and vaporized, it flows into the bottom of the distillation tower. In this way, only the refrigerant with high boiling point is selectively condensed in the distillation tower and collected at a point at the bottom of the distillation tower. Then, moving to the top of the distillation tower in the gaseous state, it is condensed and separated and purified into a high-purity single refrigerant. In addition, IoT-based technology was developed to operate and control the 24-hour system at all times. Our technology has been recognized by the Ministry of Environment for its excellence and greenness, and we have obtained 4 patents related to the technology. As discarded refrigerants are separated and purified with high purity, it can get import substitution effect on refrigerant demand, which relies only on import. And the regeneration of refrigerants that have stopped to produce due to international treaties is a strategic eco-friendly technology which can respond to demand of the national key industry, defense and industries, and contribute to solving the global warming problem. Development of high-performance abatement technology for perfluorinated compounds and nitrogen trifluoride with high destruction rate and energy efficiency. This development is supported by the R&D Center for Reduction of Non-CO2 Greenhouse Gases, funded by Korea Ministry of Environment as Global Top Environment R&D Program. Perfluorinated compounds and nitrogen trifluoride as a non-CO2 greenhouse gases widely used in semiconductor or display industry, and they should be decomposed before being emitted to the ambient. Lower PFC's destruction rate and excessive energy consumption are most big issues for the conventional abatement system for perfluorinated compounds and nitrogen trifluoride destruction. In order to overcome those lower perfluorinated compounds destruction and excessive energy consumption users, we developed the new abatement system for perfluorinated compounds and nitrogen trifluoride. Our system can destruct the perfluorinated compounds up to 95%, with saving the energy over 30% compared to the conventional abatement system. Key technology is excess enthalpy combustion technology, which can realize the effective and energy-efficient destruction. The combination in porous medium is a sort of self-recuperative combustion. The waste gas, including perfluorinated compounds, mix with fuel and oxidizer, and then the pre-mixed combustion occurs in a porous medium, which has high thermal conductivity and radiation emissivity. So, the high-temperature heat generated from combustion is directly transferred to the waste gases, and this direct heat transfer to the waste gas and internal heat recirculation by porous medium can realize effective and energy-efficient perfluorinated compounds destruction. Another key technology to realize the effective and energy-efficient destruction is appropriate enrichment using pressure swing absorption technology. The main principle of PSA technology is to separate and exhaust the nitrogen selectively, up to 50% in the waste gases, and then it makes decrement the load of combustor. Dry particle collecting technology is also applied in front of PSA system. To remove hydrogen fluoride, which generated from the combustor by destruction of perfluorinated compounds and nitrogen trifluoride, the high-performance wet scrubber is also applied at the rear of combustor. We expect our development abatement system contributes to improve the atmospheric environment applying to the various industry. Development of perfluorinated compounds treatment and recycling system using reaction-enhanced RCS. About 10 to 50% of perfluorinated compounds used in semiconductor, liquid crystal, and solar cell manufacturing processes are discharged unreacted into the atmosphere. Our system is an economical processing system that can remain energy usage below 0.1 kilowatt-hour per normal cubic meter through low-temperature operation and waste heat recovery. Hydrogen fluoride generated during the decomposition of tetrafluoromethane is continuously removed by using solid phase reducing agents such as calcium oxide, calcium carbonate, etc. Innovative technology that can lower the reaction temperature and fundamentally block hydrogen fluoride efflux. These RCSs originally blocks hydrogen fluoride emitted from the RCS. To maximize energy efficiency by easy recovery of waste heat through a heat exchanger. To reduce catalyst durability by hydrofluoric acid. To maximize energy efficiency and improve catalyst durability by low temperature operation. To compact process due to elimination of back-end hydrofluoride absorption process. To recover resources by production of calcium fluoride. Development of small-scale air cooling system using eco-friendly natural refrigerants. Hydrofluorocarbons, which are hydrofluorocarbon refrigerants with very high global warming potential, are mainly used for household and automotive air conditioners. As the global warming problem becomes more serious, there is a growing interest in using eco-friendly refrigerants with low global warming potential to replace such refrigerants. Carbon dioxide is one of eco-friendly natural refrigerants with a remarkably low global warming index. Carbon dioxide is safe, non-toxic, and earth-abundant natural refrigerant, which has been used for long decades before synthetic refrigerants, such as chlorofluorocarbons, hydrofluorocarbons, were commercialized. However, since the existing cooling technology using carbon dioxide as a refrigerant has an extremely high operating pressure, it has been difficult to apply it to small air conditioners such as household and automobile ones. Our new cooling technology that can effectively use eco-friendly carbon dioxide natural refrigerants, even at low pressure, has the characteristics of safe and easy maintenance. Therefore, it can be used for small air conditioners. Whereas the conventional cooling technology is cooled using the principle of vaporization and liquefaction of the refrigerant, our technology includes co-fluids capable to absorb a refrigerant together with the refrigerant in the cooler, and utilizes the principle of absorption and desorption of the refrigerant in co-fluids. We have firstly developed the co-fluid candidate materials, which can effectively absorb and desorb a carbon dioxide natural refrigerant, and circulate safely and effectively in a cooler. We have also developed the production process of these co-fluids in economic ways. Moreover, we have demonstrated the new air conditioning system using a carbon dioxide natural refrigerant and operating under relatively low pressure by introducing co-fluids in the cooling system. Our technology can reduce the use of global warming gases in use of air conditioner refrigerants, such as hydrofluorocarbons, by utilizing carbon dioxide natural refrigerant with low global warming potential. In addition, we hope our technology can be easily applied to domestic and automobile air conditioning, because of lower operating pressure of carbon dioxide refrigeration system with our new technology. Development of greenhouse gases removal system by using combined pump and scrubber technology. Frequent cleaning, operating costs, and excessive energy are used due to efficiency reduction of existing POU scrubber used in the semiconductor process and clogging of piping of a shear pump. In the process of treating fluorine compounds, there are problems of discharging secondary pollutants such as gaseous pollutants and ultrafine particles. We have developed the integrated pump and scrubber greenhouse gas reduction equipment to improve this. Our technology can be installed without the restriction of the internal space of process by integrating the back-end pump of the main equipment in semiconductor processing with the scrubber. And it is possible to save energy by using the POU scrubber, whose structure is different from existing one when decomposing gas. In addition, as it is possible to easily exchange heat between a pump and a scrubber due to differentiated utility structure, the prevention of powder accumulation in pump piping, and the increase of the temperatures of plasma shear improve gas decomposition efficiency to prevent existing heat energy loss and enable efficient operation by reducing frequent cleaning cycle. By rotating a nitrogen tube in the pipe wall inside a plasma reactor, the high heat of the reactor is received and delivered to gas piping at the rear end pump, and then enters the nitrogen injection section of a plasma torch. The nitrogen, whose temperatures have risen, is delivered to gas piping at the rear end pump, and then enters the nitrogen injection section of the plasma torch. This structure increases temperatures before entering a nitrogen torch to assure the safe combustion of gas, and simultaneously wraps the location where nitrogen line applies a double jacket to the rear end pump to solve the existing powder accumulation and help smooth gas treatment efficiency. In addition, heated nitrogen enters the front of the torch to raise the temperatures of the whole fluid, which can keep the internal temperatures of the chamber constant with little energy. By combining CDA or nitrogen injection part utility on the bottom of this equipment, efficient cooling is enabled and secondary nitrogen oxide can be drastically reduced. Integrated pump and scrubber system can efficiently treat harmful gas and simultaneously save energy. The technology can be applied not only to semiconductor process, but also to the treatment of exhaust gas generated in the general industry.